Hi friends, let us start a new chapter today, that is gravitation. First I don't want to explain what is gravitation. First I want to show one thing, that let us consider these are two balls. Okay, so these are the two balls and each ball have mass m1 and m2. So mass of this ball is m1 and mass of this ball is m2. So here it is a ball, we know. So here I am saying ball, and I will generalize this as a body. That means any body which has mass. Okay, these are the two bodies which has mass m1 and m2. So in our solar system, what happens? Any two bodies or particles which have mass, they attracts each other. They attracts each other like this. Okay, they are separated by some distance r, and as both the objects have mass, therefore they attracts each other. They attracts each other. So the force of attraction between the two objects depends upon the mass of each bodies. Okay, that means the force of attraction is directly proportional to the product of their masses, that is m1 multiplied by m2. And also what happens, if the separation of these two balls or two objects are small, then the force of attraction between them is strong, and these are separated by distance, large distance. That means their force of attraction will be weaker. Okay, so we can say that the force of attraction between the two mass objects is inversely proportional to their distance. Not only distance, but square of their distance. If they are separated by 2 meter, the effect on force will be 4 meter, due to 4 meter separation. Okay, if they are separated by 3 meter distance, then their force of interaction decreases by 1/9. That means 3 square, that is 9. That means as if they are separated by 9 meter distance. So force of attraction decreases as the separation increases. So we can say that the force of attraction between the mass objects is directly proportional to the product of their masses and inversely proportional to the square of their distances between them. One thing here is that their separation, how the separation of the objects are measured from one surface to another? No. The distance between the two objects are measured from the center of the object. From the center of this object or ball to the center of this object. So the separation will be what? The appeared separation between, that means the surface separation, as well as the sum of the radius of the two balls or two objects. If it is a spherical object, then we can say radius, and for another type of objects also the center points are measured to find the distance between the objects. So this force of attraction is called gravitation. This force of attraction due to the mass objects, as they are having mass, the force of attraction of the two objects due to their masses is called the force of attraction or gravitational force. So this gravitational force is sometimes called gravity. When we say gravity, so if I have two balls here, if one of the object is ball and another object is earth, okay, another object is earth, okay, so it is rotating. If one of the object is ball and another object is earth, then also there is a force of attraction between the two objects. That means ball has some definite mass as well as the earth has mass, okay, so both the mass objects attracts each other, and the force of attraction is now called gravity. If one of the object is earth and another is any object, then the force of attraction is called gravity. So here also the separation between the object and earth is measured from the center of the ball to the center of the earth, okay, from the center of the ball to the center of the earth. The separation between the two objects is measured from the center of earth to the center of the ball, and mass is multiplied with another one. So force of gravity or gravity is directly proportional to the product of the mass of earth to the mass of the object, and inversely proportional to the square of their distance between them. So the expression for force can be written as, so this is the expression. We have drawn the two mass bodies like this and separated by distance r. The force of attraction between both the objects is the product of m1 m2 and inversely proportional to 1 by r square. So here F equal to Z, capital Z, m1 m2 by r square. This G is the proportionality constant. This G is the proportionality constant. In SI unit, we have capital Z is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square. This value is same everywhere in the universe. So this is called a universal gravitation, law of gravitation. This law states that every particle of matter in the universe attracts every other particle. That means every particle of matter in the universe, all over universe, attracts another particle with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So both forces acting along same line and they are directed toward each other. So there is some special features of gravitational force. The gravitational force between the two bodies constitute an action and reaction pair. That means if one object attracts towards itself, then another one also attracts to itself. So the forces are equal in magnitude but opposite in direction. They are equal in magnitude but opposite in direction. So it forms an action-reaction pair. So the strength of gravitational force of attraction is independent of the medium. That means at what medium the two objects are, or what is the medium between the two objects or mass objects. So the nature of the medium is irrelevant here. The gravitational force of attraction between the two bodies are independent of the intervening medium between them. The gravitational force between two bodies does not depend upon the presence or absence of another bodies. Let us consider if there are four mass particles and all the four mass particles are attracting towards each other by everyone, but the strength of the force on one pair is not disturbed by the presence of the other objects. So the force of attraction does not depend upon the presence or absence of other bodies. And last one, the gravitational force of attraction is extremely small for infinite particles. That means infinitesimally small particles, but it is of appreciable magnitude in case of highly massive objects. For example, the force of gravitation in case of electrons and proton is negligible due to their very small masses, but the force of attraction between sun and the earth or sun and any other planet is appreciably large. The force of attraction between sun and earth is nearly in the order of 10 to the power 27 Newton. Some examples of gravitational force are what? When we draw, when we left a part object like this, if we like this, what happens? The due to force of gravitation, the object fall towards the ground. Here I have hand here, so it do not reach the ground. But when we leave ball from a certain height, what happens? It fall towards earth. So this shows that the presence of gravitational force. I will discuss again these points after a few points here. So another evidence is what? Rotation of earth is due to gravitational force of attraction between earth and the sun. Otherwise, the speed of earth is so large that it flew from the orbit of the earth if there is no gravitational force. And third one is that the rotation of moon around the earth. The rotation of moon around the earth or revolving around the earth is due to the Newton's law of gravitation or gravitational force of attraction. From this case, I want to explain something is that we are observing that when we I leave my hand, the ball fall downward. So what does it mean? That only one object move due to force of attraction or both? Here I want to show with this globe. Okay, see, our earth is very large compared to this ball. Okay, our earth is very large in size compared to the size of the ball, but there is equal force of attraction between both the objects. Whatever is the amount of force acting on the ball due to earth is also equal to the same amount of force experienced by the earth due to this ball. So we can think that a ball is moving towards the earth, ball is falling towards the earth, but why earth do not move toward the ball? Isn't it? Ball falling toward the ground, but earth is not moving, isn't? So from this case, I want to say that if there is a force of attraction, equal amount of force of attraction is acting on both the particles, but we can see only the motion of the ball because it is small. Because it is small, so we can see the motion of the ball towards the earth. But due to the large size of the earth, and obviously we are on the surface of the earth, because it is large compared to the size of the ball, we cannot see or we cannot observe the motion of the earth toward the ball as we are on the surface of the earth. Is it clear? how much distance the ball can travel towards the earth, similar amount of distance, we can say earth is moving towards the sun, ball. But due to the large size of the earth or planet, we can't observe the motion of the earth. Is it clear? So from the concept of force of gravitation or gravity, we can define the weight of a substance or weight of a body. It is the force acting on the body towards the center of the earth. So what is weight? It is the force acting on the body towards the center of earth is called weight. So the object move towards the surface of the earth. As the body moves, velocity changes, and due to the velocity change with respect to time, we can measure acceleration. So the change in velocity of the object due to the force of gravitation or gravity, we can say it as a body is accelerating. So the acceleration of the object can be defined as the acceleration due to gravity. So what is acceleration due to gravity? The acceleration produced in a body due to the force of gravity is called acceleration due to gravity. Later on, we will derive the expression for acceleration due to gravity and its value.